Okay, I think we're going to start it up. Let's see. Let me check to make sure it's actually working. Looks like we are indeed live. Great. Okay, I'm going to try to check my volumes. I'm aware that every time I do one of these, my voice just explodes through whatever mic I'm using. So I'll try to do a little bit of Bob Ross this time, just a little bit calm, which is totally not me, but whatever. So thanks everyone for joining. We are lucky enough to have the developer relations lead over at Jina AI, which is an open source neural search framework, Alex C-G. Is that how you introduce yourself, by the way? Alex
yeah, my parents are terrible people. They gave me a really long double-barrel surname. I sound really posh and really British, but really I'm not. I just go with CG.
Nice.
Much easier.
What is the full one, if you don't
Puritan
mind?
Griffiths.
Oh yes. Well.
Yes.
Okay.
Half French, half Welsh. Why not? Two great tastes that taste terrible together.
Well, no comment on that one. Welcome. Okay, a couple things to run through, and then I will kick it to you. And I think we've got an audience that will be mostly from the Label Studio community, but there may be some folks here from Jina AI as well. For anyone who's not already in our Slack channel, please join if you want to ask questions, and just join in general. It's a good idea. You can get answers to any questions you might have about Label Studio. The engineering team is actually very responsive, ridiculously so, I would say. These people don't sleep. But we're all about the community here. It's a point of emphasis, so it's definitely valuable to join if you haven't already. Also, on our website, we have an updated page of webinars that are coming up. You can RSVP for any ones that interest you and get a calendar invite and reminders. We'll be adding more details and more webinars, obviously, as time goes on, and we're trying to get more further out so you can actually plan ahead, and we're making some really good progress with conversations with some exciting other communities in the MLOps space that you may want to see interviewed. You can also look at past webinars that we've done and watch the YouTube replays. Something to note, these live stream links stop working after we do the live streams. We like to just edit the beginning and end of them a little bit and repost them. So if you've seen a live stream and you want to watch it again, check the links on the webinars page. So obviously I'll let you introduce your tool, but if you guys want to follow along or if you want to queue up some questions or read through as Alex is describing Jina, then you can go to get.jina.ai and that'll get you to the Git repo and you can get it. And for us, if anyone is not familiar with Label Studio, this is something I haven't really done much of in previous webinars, but it occurs to me I should. Why not? Here are a few links for us. We are an open source data labeling tool that allows you to label, well, pretty much every data type with more coming, which doesn't make much sense, but we aim to cover all of the viable data types. Labelstud.io is a great way to check out the open source. We've got a playground. You can play around with different scenarios and setups. Heartex, you can look at all different editions. We do have an enterprise edition as well as a Teams edition. We do a monthly newsletter. If you want to check that out, it's at Substack, labelstudio.substack.com. And of course, trusty Git repo right here, which you can also get to from the website from any of these other links as well. Those are all of my plugs. And yeah, I'd like to kick it to you now, Alex, if you want to take it away.
All right. Thanks, Michael. Yeah, as Michael said, I am the developer relations lead for Jina AI. We're a startup based in Berlin, Germany, because what other Berlins are there? I mean, there probably aren't that many AI startups wherever they are. So yeah, we provide an AI-powered search framework, totally open source, and I'll dig into that. A little bit about how it works, what it can do, you know, the whole shebang, all the goodness. So I'll start by sharing my screen, and we will go from there. Okay. Can you see this, Michael?
I sure can. Cute little astronauts and whatnot.
Awesome. Yeah, I have given this, well, presented this deck so many times, and I just have not had time to create something custom, but this really dives into Jina and how it works. So we'll start from there. So Jina is all about search, and it's all about solving problems. In this deck, it's normally meant for a workshop, hence the word workshop there. And it's about building a search engine for memes. So we'll look at the problem formulation a little bit. Then we'll go into what Jina is. And if we have time, we'll go through a bit of the code to give you an understanding. It's very straightforward. If you don't have a background in deep learning and AI, don't worry. Because, man, I majored in Chinese at university. Everything I know about Python, AI, deep learning, I learned from anti-YouTube. So, I'm no expert. And thankfully, hey, I don't have to be. This stuff is powerful, but pretty damn easy. Even if I do say so myself. Right, so let's say we want to solve a problem. We want to build a search engine for memes. We've all seen the Winnie the Pooh memes, and you know the one I mean. Winnie the Pooh in the red shirt at the top and the dignified Winnie the Pooh with a monocle and a tuxedo at the bottom. So let's try to find memes about Winnie the Pooh that deal with food, right? And in the meme search engine we actually built, this is what comes up. And it's kind of interesting because, yes, we can see the pictures of Winnie the Pooh. And in some of these, we see the words food as well, like finger food, hors d'oeuvres. But some of them we really don't. We see things like cereal and breakfast soup, and eating Cheetos and eating cheese puffs. And as I said, we're AI powered. We're dealing with language models that have been pre-trained with a whole bunch of data. So the models already know that cereal and breakfast soup, well, cereal and breakfast and soup are all food words. And I guess it knows that eating the Cheetos and cheese puffs are, well, considered food by some people at least. So it has a mental model of how things work. Or we could also just search one keyword like chocolate. And then we get a whole bunch of memes about chocolate, memes with different templates. So we've actually got a working example of this at examples.jina.ai. I can show you that now. Actually, we've got this open. So if we go here, we've got our meme search. Front end built in Streamlit because my JavaScript and CSS are terrible. So I really hope our AWS backend hasn't fallen over again. I'm no DevOps guy. So let's do a quick search, like So You're Telling Me with Willy Wonka. We can see it's running. Sometimes takes a little while to spin up the first time round. Oh, demo effect, how I love you.
You named it, so of course it's going to happen.
Yep. Yep, I cursed myself. Okay, I need to go to wherever our instance is and kick that server in the motherboard. So, right, that's not going to work, tragically. I'll try to get that going tomorrow, so you won't miss out on all the meme goodness. Right, but yes, essentially what I built there with my own two hands was a search engine for memes. You can type in text and it'll find memes with similar text. Or you can upload an image, it'll find memes with similar images. And that's what Jina is really good at, for searching any kind of data. And I'll dig into that a little bit more. So normally in the workshop, I go over all of this stuff. I imagine you can all read, so I'm not going to step you through this slides. But first of all, when we think of search, what do we think about? Typically this kind of thing, right? Google or Twitter or, Stack Overflow. We think of a text box. But really search is so much more than that nowadays. Maybe you want to find similar PDFs to a PDF you upload. That's a case of search. Or similar videos, or you really like Beyonce and want to find similar songs. Or, when you use your App Store search, you're, searching. Image search is really great for e-commerce. let's say I'm building the next Amazon. I want my customers to be able to upload pictures of shoes they see a celebrity wearing and find cheaper knockoffs. Nice use case. And also chatbots are a case of search when you think about it. You know, you're only getting one result back, but it's searching through a database for what could the right answer be. Even things like Tinder are search. You know, based on your preferences, it's searching for people it thinks you might like, or that will make you keep feeding its algorithm in that case. But what's neural search? So with neural search, we're using the embeddings from deep learning models to do similarity search. So let's say you take a model like Clip, which is really good for encoding images, and you feed some images into it. So you can feed in some Bulbasaurs, and because Clip does feature detection, it'll look at, oh, it's got these cute curves. Oh, it's green and it's got some spots. Or you could feed a Charmander and it'll go, oh, it's got a sort of fiery tail, it's very orange, around its snoot, all of that. And it could place them onto a graph. This is very simplified, but it could be however many dimensions you want, usually more than 3 dimensions, so I can't really put it on a screen. What Jina allows you to do is use these models. Instead of just encoding, it'll let you do similarity search. So if you upload a picture of Bulbasaur like this and ask it to find similar images, it'll find a picture of Bulbasaur like this, because the points on the graph are very similar, going with approximate nearest neighbor. So the advantages of this is that it's semantic. It actually understands the meaning. Like I said, Clip does feature detection. So it's seeing the rounded things. It's maybe detecting an eye here or there. It's getting the picture in a way, well, it's a neural net. And you and I have got neural nets. They're just made of meat and wrapped up in a big bone of ball. But yeah, the ones I'm talking about here are based on silicon. Well, silicon, not silicone, that would be weird. But yeah, they do the same thing as our brains. They understand meaning, or at least some form of meaning. Like the human brain as well, it's data type agnostic. I can look at 2 Pikachu and see that they're similar. Or I can read 2, I don't know. I could read 2 books by J.K. Rowling and see that they're similar. I was going to say Shakespeare, but yeah, I really don't want to do that. And also there's a wide array of models. Just like humans have different ways of looking at the world and inferring patterns. There are a whole bunch of different neural net models as well that can do that. So my French sucks. So if I wanted to build a search engine for French, you know, my brain would be useless. But with these neural networks, and especially with Jina, you can pull out the English-speaking brain, put in a French-speaking brain, just with 1 or 2 lines of code. Now, that's all well and good. You know, deep learning, machine learning, embeddings, vectors, all those sexy buzzwords sound great in theory. Integrating all of this into a thing that works and scales when you're using multiple moving parts, that is tricky. So that's where Jina comes in. We solve a lot of the infrastructure and the optimization sides of things. So yeah, in short, we're about providing an open source neural search ecosystem, lets you search for any kind of information with high availability and scalability. We can search pretty much any kind of data. If a neural network can understand it, you can plug it into Jina to use it to search things. So yeah, all of these things you can read. I don't need to go through them, but we've got some examples on our showcase, which, wow, I really hope that one isn't down. If that's down, someone else at work is having a bad day tomorrow. So yeah, we've got one here. So for text-based search, we can have a short text input and find similar PDFs. So for example, what is transfer learning? And these PDFs reference these things. We're not going to go through them right now because we do not have time for that. And I should mention that this showcase site it really is just about demoing features. It's not going to be perfect, because to get amazing results, you would have to index a whole load of data, because that's the way it works with AI. And this has only indexed a few thousand, but it gives you an idea, right? E-commerce. As I said, you can find similar things based on an input image. So let's find some nice shoes. Oh, yeah, this is just a diagram of how it works behind the scenes. We can hide that. But yeah, like I said, not perfect. If we threw more data at it, it would give us better results. But we could also say, yeah, shoes, but blue. So we're saying an image and we're giving it a text descriptor as well. And then it's finding sneakers that are blue. And my personal favorite is the gaming one. And you might be looking at it saying, what the hell is this? Some dome, some weird black thing, and it looks like a sonic screwdriver. But no, these are 3D models. So a baseball cap, a piano, and some sort of shooty bang bang gun. I do not know my guns. I'll leave it to my American colleague to tell everyone more about the wonders of firearms. But yes, as you can see, we give it a model of a gun and it'll find guns, or because it's a limited data set, it sometimes gets a bit confused, or it'll give us something that, I mean, if you use your imagination, you could hold that like a gun or like pianos. So, and the nice thing about this one, I accidentally found out, if you open it on mobile, there's the option to project the 3D mesh into your surroundings and manipulate it. You can scale it, you can rotate it just with your fingers. So yeah, I was on the subway a while ago and just playing with a piano on the floor on my phone. It was pretty wild. All right, once more onto the breach. By the deck. All of those are showcase.jina.ai, and unlike the meme search, they work. So with Jina, we have 3 basic concepts. Man, with 1.x, it used to be a lot more, and that was a nightmare. But now we boiled it down to 3. So a document is a basic type of data. Hang on, I'm going to turn on the light. I hope that's a little better. I can't actually see myself since I'm presenting.
You look great.
So, oh, thank you, darling. I try. So we've got a document, and a document is the most fundamental unit of information you want to search for. So that could be a paragraph of text. Let's say, yeah, it could be a book, if that's the thing you want to search through. It could be an image, a video, an amino acid, whatever kind of data you want to search. We have an executor, and an executor does a simple thing to a document, does one simple thing. So if you're taking Harry Potter and you want to be able to search through it, well, I mean, that's a whole damn book. So you need to break it down. You want to cut it up into segments. So you'd use a segmenter. And then each segment you would encode. So you would put it on that vector embedding graph. So the neural network would have its own understanding. And then, you know, in the real world, if you want to look something up in a dead tree book, in a paper book, you would use an index. And you would want to build an index here as well for fast searching. And each of these simple tasks, an executor would perform each of those. And then when you put them all together, you put them into a flow. And the flow performs a more complex task. In terms of search, the main 2 tasks are indexing, where you build the big index of the data set that you want to search through, and then querying, when you pass the flow an input document and you want to find similar input documents. Personally, for me, I'm a huge Linux geek, so I think of it a lot like Bash. So we have our document, and then we have our executors. In Bash or Unix, these would be commands. And then we pipe them all together with, well, pipes. And this whole thing would be a flow. And you can see it here. That would be exactly how we do it. But we've recently introduced Jina Hub as well. So Jina Hub is, I think, they're like apt-get or brew install, which I guess Mac people use, or I'm sorry, Windows users. I don't think there's really anything good for you in that. The analogy breaks down. So if you wanted to install a cool new encoder, you go apt-get install new encoder. If you are working in Unix, and this is just an analogy, this won't actually work in Unix, but in Jina, you would just go Jina Hub : cool new encoder. It would download it to your computer. You don't have to write a line of code for that cool new encoder, and it will just run it as if you wrote it. So yeah, the main things we offer right now are Jina Core and Jina Hub. Jina Hub, as I mentioned. Well, let's take a quick look at that. Show, don't tell, right?
Right.
Come on. Come on, baby, you can do it. So yeah, in Jina Hub, we have a whole bunch of pre-built executors for you to use. We have things like transformer torch encoder. So you may be familiar with PyTorch with Hugging Face transformers. As I said, a sententizer to split things into sentences, ranking, clip image encoder, clip being one of the state-of-the-art image models at the moment, and a whole bunch. And anyone, this is public, you can upload your own executors to this. You can download other people's ones. If you want them to be private, your own ones, so you only share them with people in your company, you can do that as well. This is still pretty new, so we really want people to use this. And believe me, it makes everything so much easier, much, much fewer lines of code. Because all you really have to do is add it to your flow. So it'll even run in Docker, so you don't need to install anything else onto your system. And then you can chain that with a sententizer, with an indexer, and so on and so forth. So if this were a full-on workshop, we would go through it a little more slowly, but we can take a quick look at how it works. So let's hop right in. So where are we? So yes, here we are in Google Colab. So you can run all of this in a notebook. There is a kitty function or a corgi function you can turn on. So if you take nothing else away from today's webinar, take that away. I think it's in Tools, Settings, Miscellaneous, Corgi mode, Kitty mode. I'm actually going to turn them off right now, just because I get distracted myself. So I dread to think how everyone else will cope. So we would start off by, this is just a very quick workshop. So we'd say, we'll set the max documents, run anyway. We can blast through this pretty fast. It's just spinning up. This is a completely public workshop. So we can, I'll share a link later and then Michael can share it with everyone else. We're just pulling the requirements file because Colab doesn't store state. If you're doing this on a local Jupyter notebook, you wouldn't have to worry about wgetting things. And it's just installing all of the requirements for Jina. And it looks like a lot, but in reality, Jina is pretty lightweight compared to a lot of other machine learning things. Okay, little green check mark. So if we're building a meme search engine, we need a meme data set. This one is from Kaggle. We're storing it on our own server. It's completely Creative Commons, public domain. I just don't want to faff around with having to do Kaggle authorization. So this is the kind of meme the data set holds. And we want to load that data up. It's a JSON file. So we're going to create a document. Well, I mentioned documents earlier, the most fundamental unit of data. And in this case, a document is a meme. So in the meme, it includes some pieces of text, which are which are just here. The template name and the meme caption. So surprised koala, this is poisonous. What? So it combines these and sets them as document text. And in this case, document text is the actual thing that we will search. And we're also going to populate some document tags. So tags are the metadata. In this case, the metadata would be the URL to the image file. We're lucky. We don't have to deal with understanding or storing the image file itself, because this is just searching memes by text. So we're indexing just plain text, and we're searching just plain text, and the images come out as metadata.
And so
we're doing this. Sorry, go ahead.
For this, so you're basically relying on the metadata that already exists around the meme. It's not doing some sort of like OCR work to recognize the text and extrapolate it or anything, right?
That's correct. If you want to build an executor to OCR things, that's certainly possible. I've built an executor to actually go through all of these memes and check if they have a dead URL or not. And if they have a dead URL, remove them from the data set. So even like little utility executors, you can write those.
Very cool.
So yeah, we put all of that in the document, and then we create a document array to hold all of these documents. And an array is just like a list in Python, or an array in any other language. So we'll import the stuff, document array. This will load up the data. If you're in this webinar, you know about the sheer joy we all get from working with different data sets. Yeah, so in this case, I've written my own loader function. If you're building something quite simple, like just a whole bunch of image files from a directory, we do have helpers, like from files or from CSV or from JSON. Those are for more, let's say those are for, if we're doing like from JSON, using that helper function, it would be JSON in a very standardized format. Whereas this JSON file is its own weird hinky thing that I had to really dig through. So we will set up that function. And we're going to shuffle these memes as well. And I'll show you why. Because let's start by not shuffling. And then let's look at the memes that come out. Okay, so come on, Google. So as you can see, it's just lots and lots of hotline bling. So not a super interesting data set to search through, right? So what happens if we do shuffle? Let's have a look. So we've got a whole bunch of things. We've got Hard Luck Harold, we've got Most Interesting Man in the World, Yoda. So a little more interesting to search through. And now we want to do something with this data. To do something, as I said, we pass it through different executors. In this case, because we're dealing with short text, we don't need to cut it up. And as I said, executors, they all live inside a flow. So we'll import the flow. And in the code here, we're going to do flow add. We are going to use Spacey text encoder. I found Spacey to be super, super fast. It indexed 200,000 memes in under 10 minutes, whereas some other models were taking a lot longer with similar quality results. We're going to say, yeah, use the medium Spacey model. By default, it just uses the small. We're going to give it a name. That always helps in debugging. And if I were building this on my own machine, I'd go Jina Hub plus Docker, because it sandboxes everything. But because we're in a notebook, it doesn't really work. So I have to pass install requirements. And then we have the indexer. And we're just going to use simple indexer because it's simple. In this case, we don't need to run a Postgres or MongoDB backend. And I don't even know how we would, because we're dealing with a notebook. So let's create the flow. So we've created it, but we haven't initialized it yet. Because the way we do it is we use it as a context manager. Here I'm just removing the workspace folder because every time the flow runs, it creates a workspace folder. We don't want that right now. We want it to do a clean run every time. So we'll say inputs is the document array that we did before, request size 64. So process 64 documents at a time. We can batch this. And remember, we only have like 50 documents. So, because we said max docs earlier. So it's pulling the spacey text encoder from Jina Hub. Always a little bit slow the first time. Fetching simple indexer. If you run this on your own machine or you run this twice in a notebook, it would be a lot faster because this stuff would be cached. And as I said, Google Colab doesn't really store state. So every time we go in and start this notebook again, it's starting from blank. Okay, see, it's done. Don't worry about all of that. I never worry about it. So now we've built up our index. So as you can see, a quick overview of the file structure. This was the input data, the memes, sample data, that's just created by Google Colab, and workspace. So that's where we store the index of the documents that we just indexed. So all of that data that we're going to search through, the vector embeddings and the metadata are in these files. So now we're going to create another document because everything we put into Jina is a document, whether you're indexing it or using it for querying, well, using it for searching, it has to be in the form of a document. Like I said, a document can be anything, any kind of data, but we're working with text, so we'll go with text. We'll just say, yeah, something simple, school. Okay, now we'll open the flow again, exactly the same flow. It will encode the text. So it'll encode the word school into a vector embedding with spacey. And then instead of putting it into the index, it will search through the index with this document and find the nearest neighbor. So let's do that. We're going to go return results true and set response to the results. I always feel like I need to play some elevator music when this is happening. Okay, and it's done. So what it returns is, it's a little complicated because it's including a lot of other data about, what's been happening, about the school document I just sent, but we just want the matches. Okay, and now let's just go through the top 5 matches, pull out the URL, get the file, and then display the file and then remove it. So remember the keyword was search. So first result, my uncle graduated from a school of fine farts. So wow. Yeah, that's valid. Because we've got a very small data set, only 50, it can't do a lot with that. So this is a bit of glitchy.
These memes, this is ridiculous.
So yeah, number 3, we've got Picard, and it's about college, MIT, Harvard. Those are definitely school related, but they're not mentioning school. So the spacey model we're using makes that connection itself with its neural net. I quite like this one because there isn't any one word that is related to school. But this is a scenario that could happen in a school.
That looks like an AI generated meme. I mean, read the sentence. What is it? I don't know.
But yeah, it's a very schooly situation.
Okay.
Walking up to a girl sitting at a table with 2 chairs and stealing the chair. I mean, hey, no judgment. Yes, judgment. If you're doing this and you're like, in your 30s or beyond.
I told her how it is, and then I sat down.
Yeah, that's something. And then the 5th one, when your parents take your phone. So maybe it's just running out of really school-related stuff here, but parents implies kids, kids implies school. So it's not doing half bad job. All of this code is completely open source. It's on my personal GitHub repo. So you can find me at github.com/AlexCG1. So we've got the image backend, which I haven't shown here, text backend, we've got the Streamlit front end, all of this. So yeah, if you go to my repo, it should be one of my pinned. Yeah, Jina meme search. It's just there. Just going back. So yeah, that was a working text search for memes. In just a few lines of code, you didn't have to deal with PyTorch or TensorFlow or any of that jazz. But if I were doing this in the real world, I would use a RESTful API because most people would access this through the web, right? Not through a notebook. So in the notebook we used, we did the search this way, but otherwise I would open a port and expose our RESTful API, and block just keeps it open. So then you could search for it using, curl or whatever framework you want. And as I said before, I would use Dockerized executors. So instead of GinaHub simple indexer, GinaHub plus Docker simple indexer. And all of those are on our hub. And we are adding more all the time. And we're always happy for you to submit yours as well. It's really straightforward. All the instructions for that are on docs.gina.ai. Yep, that's pretty much the deck. Hang on, let me go back.
I do have some questions if we have time. If you're finished.
Of course. If you want to get the notebook yourself, you can go here. And I'll share these links afterwards. Yeah, you don't need to install anything on your machine to do this. It'll just open it up straight away in Google Colab. So as a recap, Jina provides the design pattern, the document, the execute of the flow. You bring the data and it says the model, but like I said, we have a whole bunch of pre-existing models. But if you want to use your own, that's not too difficult. You can write your own executor with a minimum of fuss. But yeah, the search will only be as good as your model and your data set. If you have a data set full of cats and try to search for a dog, I mean, come on, what do you expect? And we host a whole selection of executors on Hub, as I said. So yeah, if you want to find out more, we're on all the usual places. We're really supportive on Slack. We run regular engineering all hands. You can join us. This is in IST because the last workshop I gave was in India. It is 2 p.m. Central European. Okay, so we're moving the time, so it'll be relatively earlier for people on the west coast of the USA and sort of late-ish, mid to late morning for people on the East Coast. And you can find all of these just by Googling Jina Meetup. And yeah, that's it for the deck. And more than happy to have questions.
That was a great presentation. Thank you. Wow. Really exciting stuff. Actually, if you wouldn't mind going back to that slide where the what can Jina search slide, I have questions. So, I mean, I saw text, images, audio, video, 3D mesh, and proteins. So of course I have to ask about proteins. First of all, what does that mean?
So we were working with Major League Hack, and some of the Major League Hack fellows started building a search engine for amino acids.
Oh, wow.
Let me see if I can find it. Oh wow. Can you hear me?
Yeah, I can. I can hear you.
Okay, my computer's being really laggy.
I can see that.
Okay, so protein search. Yeah, so Hugging Face has a model for searching proteins. Proteins can be encoded into basically strings. And I say strings, I mean strings of text.
Okay, okay.
So this is what a protein sequence would look like. And this model understands those sequences. So it can find similar ones.
I understand why you'd want to break that one out as opposed to putting it under text, because that's a very impressive, I guess, unique set of things to search.
It's nifty. I had not thought of it before. So this and the 3D mesh really personally impressed the hell out of me. Because
my next question, actually.
Oh, go for it.
Well, just about 3D meshes. I mean, how is it searching 3D meshes? Is it taking like a bitmap and like just doing like, no? Okay.
I believe it's actually searching the 3D model. Because if you were taking a bitmap, you'd have to do it from several different angles.
Yeah.
But there are models, I don't know which model it's using, but there certainly are ones that can understand the geometry of 3D meshes.
Okay. Okay.
I think the data set it's searching it's not just the mesh, but this is for game assets.
Okay.
So hang on, I'll just bring it up again.
Yeah, I figured that's what this was. Cool. Yeah.
So yeah, so in this case, the mesh would just be the shape itself. So whether it's yellow or blue or red, that's what humans see, but it's not the geometry. But the asset is with the skin, with other stuff as well. Potentially with animation, if you're building a game and have goodie and baddie 3D models, perhaps they move, you'd have animation, you'd have other things going on as well.
So I guess so you would submit a 3D model and it would try to find similar 3D models, essentially.
That's right. I don't know the exact format because I do a lot of 3D printing myself.
Oh,
wow. But
okay, so then
yeah.
Regarding video search, how would that work? Would this be like a text search based on metadata, like I want videos of the beach at night or romantic stuff? Yeah.
Based on the models we've seen, and we are currently building some stuff, it could be like you could upload an image and find clips on YouTube with similar shots, or you could upload a video and find similar images. Let's say you upload a video of stormtroopers from Star Wars, and your data set is all of the Star Wars movies.
Right.
With that data set, you would break it down by scene. And within those scenes, you take stills and you would index those.
Okay.
So you could search an image of stormtroopers, it would find that still, it would associate it with this scene, it would return that scene to you as a search result. Or you could type in stormtroopers. We can offer multimodal search. So basically anything to anything, as long as the models can share an embedding space. Yeah. Like Clip. Clip is well known for image search, but it also has encoders for audio data and text data.
Like
and these, I believe it's waveforms, yeah. So they all share the same embedding space. And the embedding space is basically the mental map. So, for example, let's say chainsaw. When we think of a chainsaw, we think of the word chainsaw, we think of the tool, and we think of the sound. So you could have all of those in one mental model.
Very cool.
So you could type in the word chainsaw and get back the sound and yeah, the picture, or put in the picture and get all of that back without any real manual labeling, because the model already understands these concepts.
Wow.
It's in the different forms.
All right,
I haven't played with that yet.
You haven't?
Well, I mean, okay, I haven't played with that yet. I mean, have I played with chainsaws? Yes. Have I played with integrating all of those together? Not yet, but it's certainly possible.
So that kind of brings me to my final question. I'm sure that this is a popular or something that has been tried a million times, but I actually studied musical theater in college. I went to UCLA and I studied musical theater. I can sing, I like music, and I've always wanted a search engine that could let me kind of match my sound, my waveforms to songs. So when I think of a song in my head, I can kind of hum the tune, and then have it actually provide me a list of likely matches for that. Obviously, accuracy is a thing here. So if you can't sing, if you're tone deaf, there's limits to, it's not magic, right? It's pattern matching. But I'm wondering why this hasn't already existed, if Jina solves for any of the complexities there, or could. That's
certainly something that could be built, assuming the model exists and assuming you're actually good at singing.
Right.
So it would also depend. Like, would you want it to match based on the lyrics, or on the melody, on the harmony, on the instrument it's hearing?
I think you can do lyrics matching for sure, but for me it would be the melody. And what's hard about that is the way that our brains can kind of break down music is a single line. That's what I would be humming, and you'd have to, pick the melody out of a chord. I guess the neural network would have to be able to do that and isolate it in some sense, right? To be able to match it to what I'm doing. So that's probably why it's not been done yet, or maybe it has been done and I'm just unaware of it. But that's it's like something I've always wanted to have exist. Little memory helper, really. Anyway, that's the end of my questions.
Well, I mean, just coming back to that, if the model exists, then you can integrate it into Jina, and that should be somewhat doable. It depends how good the model is.
Yeah.
Like I said, we provide the framework.
Yep.
You provide the data and the model.
Absolutely. Okay, so this has been awesome. Thank you so much. I really enjoyed the presentation. I hope others did. No one asked questions except for me. So I hopefully, let me just double check that no one's asked them in the last moment. I don't believe so. So we can leave it there unless, did you want to plug anything else last minute? I'll throw up the final slide otherwise.
Good question. What else to plug? Join us on Slack, slack.jina.ai. Go ahead, play with Jina. We would really love you to do that. So get.jina.ai for that. If you want to find me, I'm Alex C-G on Twitter.
Alex C-G.
And that's probably the best way to talk to me. Or you can just talk to me on Slack. That works too.
Awesome. Well, thanks, Alex, for your time and for joining us. And thanks, everyone.
Thank you.
Have a good one.
Have a good one.